Hello, welcome to another edition of JavaScript Funct-on-ions. As you can probably tell if you've been following along, I am getting better at being able to fluently off of the tongue say Funct-onions. If you joined me in day one, it was very difficult to be able to put the onions together into functions. So I'm getting better at that. Today, I wanted to take the time to take a look at the class that's been introduced to ES6 and how it breaks down in the abstract syntax tree. So, in order to see how the JavaScript engine uh, takes the code that is written and then with the syntax tree breaks it down into tokens in order to be able to then take it down to an assembly level and be able to comprehend and understand and do all the binary stuff that needs to be done. So at the level from the syntax tree, it's helpful for me to be able to really understand the going ons of what is happening, especially considering the fact that we have gone from functions, declarations, and to now being able to use the object oriented, if you want to call it, approach of the class keyword. We'll find some things of interest that I've been finding with using the looking at the abstract at the syntax tree, and I just want to see if we can't identify together what it is that the tree looks at as it breaks down what's called the program. So here I've taken some code, and this comes from I just copied and pasted it from a course that I've been watching from Tyler McGinnis about advanced JavaScript. So I just figured I would just copy and paste it in and see what we can find out about what it is that is going on with this program. I'm going to be able to highlight certain aspects of the code, as you'll see here, and then we'll be able to, as we're breaking down the code, to be able to highlight just specific parts. So that should be helpful for us. So if we're going to start, we can just start at the top level, and that starts at the class, the whole class itself. And this right here is a class declaration, and within this class declaration is made up of an identifier, which is the animal, and then the body. So the identifier is pretty simple, and that's obviously just the name of the class. Now, obviously, the identifier is important because it's a binding that we're able to grab onto as we're needing it when we new up at some other point in time inside of the bigger program. So then now that we have an identifier for our declaration, we can take a look inside of the body of the class. What we're going to see here is that inside of here is that we have 4 method definitions. Now the method is one of those other personalities, as I like to call it, for functions, because they're called methods, but really they're nothing else, nothing more than functions, and that's pretty much the easiest way to put it for you. That if we want to look at this first method, it looks like it's like a super important aspect of the class, which it does have some importance, but there's really nothing different than this constructor method definition compared to this eat method definition. They're both functions, and I'm not going to go into necessarily the inner workings of the constructor function itself, But it is what it is, and that is a function. Now, the one thing that I could say that we will find a little bit different is that for the syntax tree itself, when it identifies the tokens for these these different namings and the different code, I guess you could say, is that this method definition has some extra information, metadata, that's underneath of it. And so even though it's a method definition of type no different than the eat method definition below it, is that there's a metadata underneath of the method definition that is, it's kind. What kind of method definition is this? And it just so happens that this method definition is of kind constructor, whereas the rest of these are, so like this one right here is a method. So with the method definitions, there's metadata. There's a type. There's a kind, static, computed. We'll look at the key and the values here in a moment. But so the one separating differential between the eat method and the constructor method is the kind that the tree identifies underneath of the hood. So the constructor itself has its own kind. Inside of the method definition is that we have one piece of metadata that is called the key. And so the key itself is the identifier. And the identifier pretty much is straightforward. It's a name, and the name is constructor. So we have an identifier for this, and it's a key value pair for the method definition. As we've seen in previous times with older JavaScript functions, is that you always had to have it to where it looked like a key value pair. So, before it used to be to where, you would have, this. And so, but now we're able to just go ahead and just simplify it. And that allows us to where we're able to do a little bit less typing, I guess you could say. But it still is a key value pair. And so the value of this is a function expression. So this is kind of where we've got the hidden aspects of the function that hides itself in the method itself. And so the function expression we'll look at here, it has two parameters that we look at are both identifiers, and one of them is the name and the other one is energy. Not too much that is hidden behind either of those. They're just identifiers as parameters that when arguments are passed in, is that they're able to be used to identify those arguments and then be able to pass them in. Then when we go into the block of the statement here inside of the method, is that we're going to have two parts of this. And both of them are expression statements. And so the first one here is an expression statement. And what we have on this one is that we have a left-hand side and a right-hand side. And they are separated with an operator. And that operator is the equal sign. And on the left-hand side, we have what's called a member expression. Now, what's called a member expression is pretty interesting, because this is a method definition, and then inside of it we have a member expression. Now a member expression is pretty interesting because it can help you to think about a member is being that it comes down to this. So, and this, what comes down to this, this not being this. I don't know if that makes sense, but what we have is that we have a property with an identifier of name that is on the object, which is this expression. So it's an expression, and the way I like to look at it is that the name is the actual member of this. So that's how I like to look at it from a point of view of being able to remember that this is a member expression. So we're expressing that we want to be able to put the right-hand side value and store it into the name on this. And so so the name itself is a member of this. And then if we move ourselves over to the right-hand side, we have an identifier, and that is name. And the identifier name is good way of looking at the identity of the actual parameter that we passed in, which is an identifier itself being of name. So let's knock this down here. And so the one takeaway from this itself, let me just roll this up a little bit, of this method definition is that underneath of the hood is that there's a piece of metadata that is called kind. And it's this kind so particularly happens to be of a constructor. So that's important information that is helpful when building out the tree, to be able to for the engine to know, okay, this is a constructor method as opposed to a method itself. But what we saw there again is that with this is that we have a function expression that is the value for the constructor identifier. Now, if we go down, let me just close up this one. Let's open up this next one here. And this is the eat definition for the for this member, for this method, I'm sorry. This, I'm still getting further into these and still using the uhs in between when I'm trying to figure out what I'm saying. This method definition right here, the kind, which is a piece of data, metadata underneath of this method definition, is a method. And that's got some other metadata that's found underneath of it that is helpful for the engine as it's parsing this out to understand more about the identity of this particular method. Now, so we have the key value again, just like we did with the constructor, where we've got the key and then we've got the value. So the key again is as we've been seeing, our identifiers, and they have a piece of data that stores the name, which is eat, and so it's pretty much it's a string. And then we've got a function expression again. So all four of these, 1, 2, 3, 4, yeah, all four of these methods are all function expressions. Now, really, again, we've got a parameter that we're passing in, and it's an identifier that's got a name of amount. Now, if we get into this body, it's a little bit different, and we'll be able to see some more about the way that we're able to break down the tokens that are in this particular expression. This is an expression statement. And so with an expression statement, we've got a call. And so inside of the call, we've got the member expression. And so that's the callee. And then this is the argument. So with the call expression is that you've got two parts of the call expression itself. And so with the call, you've got the callee, and you've got the arguments that are passed in. If we're going to look at the callee itself, is that we've got a object and we've got a property. So the object is the console and the property is log. So what that tells us is that we know that there is a property on the object. So the object being the console, And then we know that the console object itself has a property, and that is log. So when we actually call the object console, and then we look up the identifier for the property, which is the log, then when we call that, we know that we're going to pass in a template literal. Template literals are something I'm still exploring and trying to understand from the syntax tree point of view, is because they got what's called quasis, and I'm still trying to wrap my head around it. But what we can see is that we do have an expression inside of here, and that expression is wrapped in these braces, and that's part of the template literal syntax that has been introduced with ES6. And in order to be able to interpolate this expression, this template literal, we this part of the template literal is that we actually have to be able to wrap it in the $ and braces. And then inside of there, we'll actually be able to interpolate what exactly we have. And from this, we can tell that we have a object, which is this. And then on that object, we have a property, and that is an identifier. And the identifier is name. So again, just like with the console.log, is that the console is the object, and so when it goes and looks at that object, it's expecting to find a property log. Same thing happens here, is that when this interpolation happens inside of the template literal, is that it's first going to find this being the object, and then the property on that object. So in order for this to interpolate properly, this is that there has to be an identifier for the property, which has the of name, found on the object. And so this is the object. If we close this up, we've got this whole quasis, and the quasi itself has two parts of the template element. So this is the literal, the whole actual template. And then we've got two parts of the template, and we've got elements that are inside of the template literal. And so the first element itself is got some values that are stored into the data, metadata. And the values are, there's two key key values that are part of this, and it's raw and cooked. Now, I bring that up, and I'm not going to explain it because I really don't know much about it, but it's interesting because the second part of the template element, the literal, is a template element, and this, that the values that are stored in here have the raw being as is eating and cooked as is eating. So I have a feeling that, because this is already identified, uh, so when it's broken down, is that it's what am I looking to say here? It's already identified as what the raw value is and what it's actually going to end up being. So like with this template element where we've got the the expression, is that at this point in time we don't know, or no, well, I guess we are the JavaScript engine. We don't know what the actual raw value is or what it's going to be until it's actually called. So that's so far my understanding of the template element. Let's close off this part here, and let me just run back up and be able to show you the next part here. Is that the line 8 here, we have a expression statement. With this expression statement is that there's an assignment that's taken place. And so this assignment is what is called an assignment expression. And so we have a left-hand side and a right-hand side, just like we did on line 4. And so the left-hand side is a member expression, and the right-hand side is an identity. And the separation is an operator, which is plus equal, and that's pretty much if if you if you're used to this is um, oh, hitting the wrong keyboard. Oh my! Now I'm really hitting the wrong keyboard. So this is no different than backing this up and saying this dot energy plus amount. And so now what happens is that if we were to do this, is that so this line right here is an assignment expression. Okay, and now on the left hand side we have a member, but now on the right hand side is that we have a binary expression. And so being a binary expression, now we have another part of having a left hand side and a right hand side to this. And here we're going to have the member, and it's a member again because we have an object, which is this, and a property, which is the energy. In between that, we have the operator plus, and then on the right hand side we have an identifier. So if we change this back to where we had it before, let's just do that. Is that now we have it to where we're back to having on the left hand side the member expression, and on the right hand side the identifier. And in between we have the operator plus equals. So the plus equals actually takes what we had before on the right hand side, which is a binary expression, and it now makes the operator to where it's a binary, to where it not only is has the plus, but then also it the equals at the same time. So it just simplifies having the binary being part of the operator. If we close off this one, let's just jump up here, is that you'll see the same things for these method definitions, and where you have the key being the identifier. And the identifier is the important part, as I continue to say, the identifier is because when I see a lot of times, it's got a method of, method eat. Really what it has to be understood is that it's an identifier, and an identifier meaning that at any time that you were to call sleep on whatever this object is that it has to be able to identify that method. And so it's got to have the identifier that the syntax tree has been able to take the name of that identifier and store it. And then, of course, we've got the hidden, not hidden, but the function expression that we have as making up this method definition. So I call this another personality of the function because it's a method definition that looks like a function and acts like a function, mainly for the fact that we actually have let me go back up here into this right here, is that we've got the brackets. So a function expression you always can tell a function simply by the fact of being able to see the parentheses. So at any time you see the parentheses, you always know that you have a function. And that's one thing, is that anytime there's no other there's no other parts of JavaScript. There's objects, strings, um, numbers, anything that can do as much as a function can do simply by having these two characters, the opening and the closing parentheses. But there's nothing here that's saying function. It's just simply the fact of the matter is that the engine knows that the opening and closing parentheses is a function. So there's the function keyword, and of course that's not going to work. But the function itself is actually this. Now you can use the function so the function. So there's where one way to look at it is that putting function in front of it does not necessarily mean much. I mean, it's got meaning, but it's not necessarily what actually makes a function. This right here is the function. So anytime that you're able to put the opening and closing parentheses around something, that's what makes it a function. And so, we can put function here, and here, let's put tree. It doesn't do anything. Okay. Now let's see what happens if we do this. Doesn't do anything. So there's nothing about having just this particular word function that is of the most importance. The most importance is the actual opening and closing parentheses. So you can always find from of what I call the multiple personalities of functions is simply the fact is that the opening and closing parentheses, anytime you're able to see those, is that's what makes up a function. So as we've gone through and kind of just broken this down in terms of the JavaScript engine and how the syntax tree breaks down the different parts of this program, we're able to see some of the highlights of the ways of the engine being able to define and store and be able to connect pieces that then when it has to then give it back to you, is that it can do so in a way that you've clearly identified what it is that your program should be doing. And we always can tell, if need be, when we're doing something wrong, just like I showed you here, is that, all right, the JavaScript engine isn't going to understand what you're doing here. The JavaScript engine doesn't understand what you're doing here. Okay, so there's parts of the tree as you write your code that the engine is going to understand, and so it understands that how particular code is written when it's inside of a class expression. Then it's going to operate in a particular way as it actually gives you back that information. I'm sorry, class declaration, not a expression. And so as we go on, like if we were to say, okay, animal, that right there is a call expression. Just wanted to make sure that, and it's a call expression simply for the fact that those right there are what tells the syntax. It tells the engine that this indeed is a function. So as you can see, I'm still working through being able to identify the workings of JavaScript and the functions, and I've come to find that using the syntax tree and how it breaks down the tokens and being able to see, the method definitions and the identifiers and the function expressions and all the metadata that's stored underneath of it helps me to understand and see this from the JavaScript engine's point of view as opposed to mine. So as I write the code, then I'm able to see how the syntax tree uh, helps the engine break it down and then be able to produce for me what it is that I was expecting it to when I gave it the information and then it returned the value back out to me. So that's, I think that covers most of what I wanted to in this one. Is that mainly the this right here? I guess we can say this. So this block, this right here, is the function expression, and so it's decorated in a way to where it's actually considered to be a method definition, but the method definition itself is because we have an identifier, and then after the identifier, we have a function expression. And it just so happens that a method definition is in itself has a particular kind, which is of a method underneath of the metadata that's in the abstract syntax tree. So I'm going to continue to sharpen my skills on the syntax tree and continue to document it in these videos. And if you're listening along and anything that you might have found, I don't know, out of scope, out of understanding, needs clarification, or is not in particularly of accurate, please share it in the comments below, and I would love to see the feedback. Thank you.